We're now going to take a look at a use case for sets by analyzing the birthday paradox. So the birthday paradox begins with a group of people and asking this question: what is the probability that two people share the same birthday? The reason it's called a paradox is that a surprisingly small number of people are needed for there to be a high chance that two people share birthdays. So if you have a group of just 23 people, there will be a 50% chance that two people share the same birthday. So this is surprising to a lot of people. You only need 23 for there to be a 50-50 shot at two people sharing the same birthday. If you have 30 people, then your probability jumps up to 70%. If there are 40 people, there'll be a 90% chance that two people share the same birthday. So this is a common problem studied when learning probability, and we're just going to implement this now in Python. So what we're going to do is we're going to write a function down here that answers this question: does anyone in a group share the same birthday? So there will be some assumptions here. We're going to generate n birthdays. These will be random numbers between 1 and 365. We're going to collect each birthday in a set, and then if the size of the set is less than n, then two people have the same birthday. Okay, so there's a couple ways to do this. I'm going to delete this pass statement down here. And this function is just going to return true or false, whether or not anyone in this group shares the same birthday. So n will be an integer. And so we're just going to generate n birthdays. And we're going to keep adding these birthdays to a set. So we haven't covered set comprehensions. That's one way to do it. But we will create an empty set like this, and now generate n random numbers between 1 and 365. I'm going to do this in a loop for I in range n. I'm going to create a random number. So I'm going to use this random module right here. Say random.randint 1, 365. So that'll create a single random number between 1 and 365. So we can call this a birthday. This will be someone's birthday. We won't have to worry about the month or not. We'll just have the day in the year, just assuming a 365-day year. Nothing too complex here with leap years. And then we're going to add this birthday to the set. So if you remember the add method, so if the birthday is already in the set, this will do nothing. Otherwise, it will add it to the set. So what we're going to do here, so it's added all of these birthdays to the set. What we want to do is determine whether or not there are two birthdays. So if the size of the set is less than n, that's the number of birthdays created, then we can conclude that two people did have the same birthday. So we're going to return here a true or false. We're going to say if the length of the set is less than n, then two people will have had the same birthday. Okay, so that is our function. Let's say shares bday, and now we can pass in, some number. So 5. This is unlikely. Only 5 people in the group to have the same birthday. Now, if we do something like 300 people, then we're very likely to have two people that share the same birthday. As we see, 40 people has a 90% chance. So if I do 40, then this should mostly be true. Now, if I do 23, this is right where it's 50-50. So I'm going to continue running this, and you can see it should oscillate back and forth between true and false because it's right at that cusp where it is a 50-50 shot. Okay, so let's just make sure we understand this function again. We're just determining whether or not a group of size n has any birthdays in common. So we first create an empty set. We're going to do this n times. So we're going to create n birthdays. And for each birthday, we're going to add it to the set. And we're going to exit the loop. And if the set has a length of less than n, then we're going to return true. Right? So that means there are two people that have the same birthday. Otherwise, the length of s will be exactly n, which means they are all unique birthdays, and return false. Okay, so that's the start of the birthday paradox.